Hello students, this is the second chapter in our series of chemical bonding in which we are going to discuss various aspects related to covalent bond. In covalent bonding, atoms fill their outermost shell by sharing their electrons between them. The first theory that explained covalent bonding between different atoms was the Lewis theory. Now let us see what exactly were the postulates of Lewis theory and how it explained covalent bonding. The Lewis theory of chemical bonding was proposed by J. N. Lewis in 1916. According to this theory, the elements try to achieve noble gas configuration, that is, 8 electrons in their outermost valence shell. The noble gas configuration is also known as the octet because of the 8 electrons. So, in order to achieve octet, either the electrons are transferred from one atom to another atom, in which case the ionic bond is formed, or the atoms share the electrons among themselves. In that case, covalent bonds are formed. In order to show covalent bonding among different atoms, it is easier to represent elements in terms of Lewis structure. In Lewis structure, we write the symbol of the element and show its valence electrons in the form of dots. Let's take an example. Hydrogen. The symbol of hydrogen is H and it has a single electron. So we'll show a dot near it. This dot represents its electron. Similarly, nitrogen. The symbol of nitrogen is N and it has 5 electrons in its outermost shell. So we'll show 5 dots surrounding nitrogen. Chlorine. The symbol of chlorine is Cl and it has 7 valence electrons. So we'll show 7 dots. This is the Lewis structure for chlorine. The Lewis theory of chemical bonding brings us to the Octet Rule. This rule states that the atoms lose, share or gain electrons in order to achieve 8 valence electrons, that is, the octet. It has been observed in many light atoms that the stability is achieved when the atom has 8 electrons in its outermost shell. Now, out of these 8 electrons, some of the electrons may be owned by the atom itself and some of the electrons can be shared with some other atom. In case of sharing, 2 electrons shared between 2 atoms constitutes a covalent bond. The atom tries to make as many bonds as possible to complete its octet. But there are some exceptions to this rule, most notably hydrogen. A hydrogen atom is stable by having just 2 electrons in its shell. There are some other examples as well which we are going to discuss very soon. Now, as we discussed that a covalent bond is formed by sharing 2 electrons between 2 atoms, we can say that the number of bonds, which is denoted by small n, is equal to the number of electrons shared divided by 2. Now let us see how a chemical bond or covalent bond, more precisely, is formed between 2 chlorine atoms. As we can see, each chlorine atom consists of 7 electrons in its outermost shell. 1, 2, 3, 4, 5, 6 and 7. So it requires one more electron to complete its octet. In order to do that, 2 chlorine atoms come close to each other. Each atom will share one of its electrons with the other atom. As you can see, these 2 electrons are being shared. This green electron belongs to this atom and this blue electron belongs to this atom. We are showing these in different colors so that we can distinguish which electron belongs to which atom. Now, if this electron is shared by this atom as well, it will now have 8 electrons in its outermost orbit. The same goes for this atom, which will now have 8 electrons in this orbit. 7 electrons of its own and 1 electron which is shared by the other atom. Thus, the octet of both these atoms is completed and they become stable by forming a chlorine molecule, Cl2, which consists of two chlorine atoms. This is the Lewis structure of chlorine molecule. As you can see, 7 electrons belong to this chlorine atom and these 7 electrons belong to this chlorine atom. Each chlorine atom will share one of its electrons with the other atom. So now if we count individually, there are 8 electrons belonging to each chlorine atom, since these two are shared by both the atoms. The next example is of ammonia. Ammonia is composed of a nitrogen atom and 3 hydrogen atoms. We know that nitrogen has 5 valence electrons. These green balls depict the valence electrons of nitrogen. As we discussed in case of hydrogen, it tends to acquire a duplet instead of an octet. That is, each hydrogen atom requires 2 electrons to gain a stability. Now, in order to achieve their stable configurations, one nitrogen atom is going to share 3 of its valence electrons with 3 hydrogen atoms. So as you can see, after sharing these 3 electrons, the nitrogen has completed its octet. 1, 2, 3, 4, 5, 6, 7, 8. Similarly, each hydrogen atom now has 2 valence electrons in ammonia molecule. This is the Lewis structure of water molecule. Oxygen atom has 6 electrons in its outermost shell. As we just discussed hydrogen, it has 1 electron and requires 1 more. So in order to gain 8 electrons, oxygen will share 2 of its electrons with 2 hydrogen atoms. So now oxygen has 8 electrons and hydrogen has 2 electrons surrounding it. The next example is of hydrogen fluoride. This is the Lewis structure of hydrogen fluoride. Fluorine has 7 valence electrons and hydrogen has 1 electron. So in order to complete fluorine's octet and hydrogen's duplet, hydrogen and fluorine will share 1 electron each. So now fluorine has 8 electrons surrounding it and hydrogen has 2 electrons. Before discussing the Lewis structures of some of the examples, we discussed that there are certain exceptions to the octet rule. We discussed how hydrogen requires 2 electrons instead of 8 to gain stability. There are some other exceptions to the octet rule as well. Let's take them one by one. The atoms which have less than 4 electrons in their outermost shell, that is their valence shell, cannot complete their octet even if they share all their valence electrons. Its examples are beryllium fluoride, BeF2, and boron trifluoride, that is BF3. Let's see how.